Greetings! Welcome to Introduction to Linear Regression, Fitting Least Squares Regression Line Part 3. So in this part, we're actually going to take a look at some datas, some actual ordered pairs, and we're going to create the scatter plot, the regression equation, take a look at some of the other fun numbers like the correlation coefficient and the coefficient of determination, and hopefully get around to actually looking at a residual plot. The data that we're going to use is built into R, so we won't need to download anything. As a matter of fact, the data we're going to use is this scatter plot from the textbook. So this is a problem actually from the book, and we'll talk a bit about which one that is in just a moment. But we need to go talk a little bit about RStudio for a second and the things we're going to need when finding the linear regression line using R. So some of the commands that will be necessary, if first of all, will be the plot command. That's our old pal. It looks a little different in this rendition because you'll notice that it's not plot x by y. There's this response, and then there's this tilde, and then predictor, and then data equals. When we're doing regression analysis, we want to kind of use that format for doing our plots. And that'll make sense here in just a moment because you're going to see also that exact same structure to the command of response tilde predictor comma data with the command lm, which is linear model. And notice we're going to want to store the results of that linear model into some sort of a variable. I just call it generically regeq. You can call it Bob, Ted, Carol, Alice. You can call it anything you want. Just remember what you name it because you're going to need that name later on. Like when we want to go find out more than what it just displays to the screen. It gives us a minimalist amount of output when we ask for linear model, but when we say give me the summary, it'll give me a lot more. If we want to know what the residuals are, I can extract those as long as I've stored my linear model into a variable, a regeq, by simply saying give me the residuals of regeq, and then again I'll come over here and I'll say, all right, I'll give those a name. I'll say let's call those data for the residuals. And then AB line, that's AB line is the command. That's what we use for adding in our regression equation line, the actual line, onto our scatter plot. That's a cumulative or summative, not cumulative, excuse me, it's an additive, that's the word I'm looking for. It's an additive command, and it adds to a previous plot. You have to have a plot open already for AB line to work, okay? So let's go back through it one more time. So this gives me the scatter plot. So that's the purpose of that command. This actually does the regression analysis. So this does the regression equation, okay? It actually gives me back the regression equation, but it actually does more than that. It gives you back the correlation coefficient. It gives you back the coefficient of determination, which is R squared. It does a hypothesis test on the intercept and the slope. It does lots and lots of things. So that's why we want to store that into regeq. Summary regeq, that's how we get to see all that cool stuff. So that's display everything we ever wanted to know about our regression. The stock output, when you just run LM, it just is going to give you the slope and the intercept. Just assuming that's what you want. It doesn't want to clutter you with a bunch of information you didn't ask for. R is kind of unique that way. This command right here, this generates the residuals and stores it into data.res. So this is how you get the residuals. All right, and then AB line, that's how we actually put the regression line onto our scatter plot. So that's the regression line on the plot. Okay, so we'll show how each of those commands work going through problem 712, which is trees. But before we do that, before we actually get into this problem and I actually go through and show you that, I want to talk a little bit more about this structure right here, this response tilde predator, excuse me, there's a Freudian for you, predictor by data. Okay, so let's go get a whiteboard here and talk about that for a minute. So if you remember back in the day, you had y equals f of x. That was the function notation that we had back when we were working in algebra. And what we said is that the output, or the dependent variable, or in our case, and now when we're working in statistics, the response variable, was equal to some function of x. Okay, so this notation that we use in statistics is very akin to the function notation. Where we're going to say is that the response variable is some function of the explanatory variable. So you can think about this very much as being akin to the function notation. It's y is given by some function of x. Okay, so we'll use that both in the plot and also in the regression notation. We'll use that both places. Now, the other part, if let's go back and just give an example here where the LM was again, is that you had your response was based upon your explanatory, and then comma, data equals. And what that does is that makes it way easier for you because you don't have to go in and extract each of the columns of the vectors independently out of the data frame. It just says go in and use this particular data frame. So you put the name of the data frame that you're using right here, and it knows that's where it's supposed to go and find the variables that you've quoted for your response variable in your explanatory variable. Okay, so hopefully that'll make sense. We'll find out here in just a moment. Okay. All right, let's go take a look at the problem at hand. It says using exercise 712 trees. The scatter plots below show the relationship between height, diameter, volume of timber in 31 felled black cherry trees. The diameter of the tree is measured 4.5 feet above the ground. So those scatter plots that were in the textbook, if you want to go back and take a look at them, or in the opening slide, those were built using R actually, and the data sets are built into R. They're not something that you have to go download. So our first goal here is to go make a scatter plot using diameter as the explanatory variable and volume as the response variable. So let's switch over to RStudio and let's go take a look. Hopefully you noticed when you got into the lab that I put a template in where all of this stuff is already in there for you, so you don't have to go and type all this stuff up. It's all ready to go. All right. So one of the things, there's a note at the end. This is in order to make the knitting work out correctly, we're going to put all of our work into one chunk at the bottom down here. So we're not going to break the chunks up between each of the problems because these are kind of cumulative. Our goal is to make this thing I've got going down over here, and we need to make sure that we do that in such a manner that each chunk talks to each other. And the only way that can happen is you put them all in the same chunk. All right, so part one, we want to make a scatter plot. But before we do that, let me back off for just a moment here and go back over and click on packages to show you where this lives. So if you go into packages and you scroll down into the D's, you'll see data sets. And if you click on data sets, and just I click on the packages tab, and you scroll down there, just a smidge until, well, actually a little more than a smidge. It's all the way down to the T's. You got to get down into the T's, and you will see the variable or the data frame referred to as trees. And notice the girth, height, and volume for black cherry trees. So if I click on trees, it gives me all the information I wanted to know about this particular data frame. So I see this data frame has three variables. It has girth, height, and volume. And notice that they are capitalized. If you don't use capitalization, it's not going to work. So let me come down here into my console here. If I can get down and scroll down where something's going to work here. My console seems to have issues. Let's not worry about that for the moment. I can do it right here. I can just type in trees, and then if I go up and execute that chunk, or just execute that, open up my console a bit so you can see it here. You'll see there's the data frame. So the first variable is girth and height and volume. So I need, in order to get R to go find what I'm looking for, I got to make sure I use the proper names. All right, so let's do that. Let's go ahead and make the scatter plot that was requested. And the way we'll do that is plot. And then I will come in. Let's see. What are my variables I'm looking for? Let's go back up and read up here. It says we want to make a scatter plot using diameter as the explanatory variable and volume as the response variable. So that means volume's got to come first, because remember the y comes first in that y tilde x notation. So it's volume and then shift, that's above your tab, it's the tick key, and then put in what? Volume is determined by the girth. Okay, so if I run that particular command, let's go ahead and run that. Come on, you. What was, it's blown up. Why is it not working? Oh my gosh, Mike, why is it not working? Well, that's a great example of a mistake. What happened is I didn't tell it to go look at the data set, right? I need to say data frame, or just data equals trees. Actually, that was a fortuitous mistake because I showed you what happens if you don't put the data command in there because it doesn't know where to go find volume and girth. But if I put data in there, now it knows where to go look for them, and it gives me back the scatter plot that I was looking for. Nice, okay? And what we see is what we learned in the last section is that this data set appears to have strong linear positive relationship. In other words, there's a good linear relationship here. Okay, now they ask us to calculate the least squares regression line using RStudio for diameter predicted by the volume of wood in cubic feet, interpret the slope and the y-intercept. Okay, so now here's where we're going to store the results here into a variable. I call it regeq, but like I said, you can call it anything you would like. It just makes sense to me, call it reg equation, equals LM for linear model. And now here's the cool thing. Just come up here and steal this command that we put into the plot just a minute ago, because it's exactly the same command we want. So I'm just going to cut and paste that down into my linear model command. I'm going to execute that, and notice it doesn't really do much for me other than it stored it. Okay, you can see over in my environment window that there is this variable called regeq now. If I go regeq down on the console, let's open up our console a bit so you can see it a little better here. Notice it gave me back the intercept and the slope. So those two numbers are the only numbers I needed for my linear regression. You got to admit that was a lot easier doing the calculation by hand like we did in the previous example. But of course, if you only have summary data, you have to do the hand calculation. You can't use this method. This is for the raw data, which in the real world, you're going to have the raw data. Okay, so down here below, we were supposed to do something about answering the question of, let's go back to part B, it says interpret the slope and the y-intercept. So calculate the least squares regression line using RStudio, and then interpret the slope and the y-intercept. So let's go ahead and give back the regression line kind of the fancy smancy way again using tech. So I'm going to open with a $sign, I'm going to do a / and I'm going to put down hat, because that's what y hat is, and then put a hat, and then equals, and then we'll put in negative 36.943 plus 5.066, okay? And then we'll close that off with a $sign. Be sure and put a closed $sign in there, otherwise it won't execute the tech without that closed $sign. It needs an open one and it needs a closed one, okay? So that gives us the regression equation, but they asked us to interpret the slope and the y-intercept. So let's think about this for a minute. Let's start off with the y-intercept. So with respect to the y, oops, wrong character there, Mike. Y-intercept, it doesn't make sense. Why? Well, because it says if you have a tree that has a girth of 0, oh my gosh, shoot, forgot to put my variable up there. Boy, I'm doing good tonight, aren't I? So that's our x variable up there. If I put in an x of 0, it tells me I have a volume of negative 36 cubic feet, and that doesn't make any sense. You cannot have negative volume, at least on this planet. Maybe Geordi in Star Trek can do that, but we're not going to get that happening. Okay, so what about the slope? For the slope, what's going on there? Well, the slope is 5.00066, okay? So what have we got going here? So remember that the slope is the rise over the run. It is the response variable divided by the explanatory variable. So our response variable was in volume, and our predictor variable or explanatory variable was in diameter. So what that tells me is that I get 5.066, an increase I should say, because we're going to make sure it's positive. 5.66 cubic feet of volume for every, let's see, what was the, it was in inches, right, for the diameter. Yeah, so the diameter was in inches and the volume was in cubic feet. For every inch increase in diameter. Okay, hopefully that's making sense. Let's go take a look at part C. It says calculate the least squares regression line, blah, blah. Okay, so go calculate r squared for the regression line and predicting the volume of the diameter of the cherry trees, and interpret the r squared in the context of the application. Plot regression line on your scatter plot using AB line. Boy, they gave us everything and they want it sugar coated. Okay, so let's go ahead and do this. So the command we're going to put back up here in the same chunk we were working in. Remember, everything is going in this chunk. We're now going to put in summary regeq. Now remember, whatever you name, don't call it regeq if you called it Bob, okay? If you said that your regression line, your LM you set equal to here was Bob, then it's got to be summary of Bob. It's the name of wherever you stored all the information on your regression equation. Okay, so let's go ahead and run that. And I'm going to really open up my console down here so we can see what's going on. You notice that we got much more information. Look at all this stuff. They gave us way more information than with just the stock LM because we wanted to know a lot more, so we asked for it. In particular, they gave us r squared. There's r squared right there. So don't worry about the adjusted one. We're going to use the multiple r squared. So r squared was equal to 0.9353. So I'm going to shrink this down a little bit. We'll look in the next section, next module, we're going to be looking at that output in quite a bit more detail, but for now we'll just get the r squared out of there. So we're going to put in $r caret squared equals, let's scroll down where I can see it here again. There we go, 0.9353. One of these years I'm going to learn to type, and that's going to be a glorious day. All right, so there we go. So now they ask us to interpret this. This means that, let's round it off here and go 94% of the variation in the response variable. In this case, the response variable is the volume of the wood. Can be explained by the regression model. In other words, what they're telling us is this. A real interesting way of thinking about it is that as the x value changes, so does the y value. And so how much of that change in y can we explain by the change in x? And it's like 94% of it. And we see that as that number gets larger, of course, more and more of our data is falling right on the line. So they're also asking for us in the same problem is to put the regression line onto our scatter plot. So we're going to go ahead and do that, and we need to use the AB line. So remember, AB line, one way of thinking AB line is its intercept by slope, just like on a regression equation. It's actually really easy to use. You just come in and grab your intercept, put that in there, and then put in your slope. You just got to give it the slope and the y-intercept, and it will add the line that has those two numbers in it. So I'm going to put in those two numbers, and then when I run that, shazam, look at that. It put in the regression line. Now you can gussy that up a little bit. If you want, you can put in comma, and you can go col for color, and you can make that equal to red or whatever color you'd like. All right. And so let's make that look a little bigger. Let me open it up for you so you can see. And so that's not a bad graph, all right? Now, obviously, if you're going to be using this in any sort of a report or a journal or someplace where you actually want to have people actually looking at it, you need to make this thing a little better. So we had a tutorial early on in the class about how to make your plots prettier. So I'm going to go back and remind you about that. I can make the xlab equal to, well, what's the xlab? It's girth in inches. You can just do that parenthetically. Let's do it that way. I'll let you get more creative if you'd like to. And then we can go comma ylab for y label, right? And the y label is equal to volume. Oh my lord. I think all the right letters were in there, just not quite close to being the right order, right? Cubic feet, okay. And then we can go main for the main title is equal to black cherry tree wood. How about that? Okay, and so now if we run that, we get that line. Let's go run the whole thing until we get down to AB line. We're running them one at a time there, and there we go. Okay, I didn't run the whole chunk. I ran them singular, one line at a time. Okay, so if we go back to the zoom here, much prettier, more informative, tells us what the units are, tells us what this thing is all about. Okay, all right, let's finish off here. We got a few more questions and then we'll be done. It says, let's see, where were we? Yep, plot the guy, looking good. Okay, we got one last thing to do, and that says give a diameter of 16 inches. What is the predicted volume of the tree? Okay, and we can actually do that right here also. All we've got to do, there is a fancier way of doing this, but I'm just going to go ahead and do it the easy way, which is to do what? Negative 36.943 plus 5.066 times 16, right? Not 26, Mike, 16. And that will give us back, let's go ahead and run that. That's the predicted cubic feet of wood for a tree with a 16-inch diameter, okay? So you would predict a volume of 44.113 cubic feet. Okay. Let's make sure we answered our question before we go on. It says, given diameter, what is the predicted volume of the tree? Alrighty then. So let's go ahead and knit this bad boy. See, make sure everything works. Sure does. Let me scroll my knitted file over so you can see a little better. Notice that it gives everything. It slices, it dices, does mounds and mounds of julienne fries. And the thing that's really nice is you notice it incorporates the scatter plot right into your document with all of the work that we did to it. Okay, so that's cool. Hopefully you got all of that. If not, watch it again because you get to do another one of these on your own. So it turns out there's another data set over here in packages under data sets called cars. So if we scroll down to that, what this is speed and stopping distance for a car that was built in 1920. So you have a data set where the first column is speed and the second column is dist for the stopping distance in feet. Okay, so go ahead and play with that. That's an interesting data set. In particular, be sure and answer, you're going to pretty much recreate what we just did using that data set to kind of make sure that you understood everything I just did. Okay, have fun and be sure and post questions if you have any.